Write down logic gates. How do you design mathematics behind logic gates, and how you can answer questions which are coming in competitive examinations or board examinations? We'll see this part in today's lecture. There are gates which are called AND gates, OR gate. Main theme will be coming from AND and OR. What's the meaning of AND gate? What's the meaning of OR gate? We'll start from the meaning of gate first, a simplified meaning. What basically is happening. Look here. Suppose you have a switch. Current, source of current is on the left side. Current is coming from left. But you know that as long as switch is open, that current cannot flow in this direction. We'll call this thing off. The off in binary calculations is equivalent to 0. When I say off, that means no current can flow. It means numerical value of off for us is 0. Remember, off means no current. Similarly, if I say that switch is closed, the moment you close the switch, if you close the switch, that means a current can flow along the length of the wire. This close means 1. Off. Off is equivalent to no. No current, 0. Yes, there is a current in the circuit. Yes stands for 1. First of all, we are interested in these two numbers. We are defining off and on. Circuit is off. Off means switch is off. Switch is on, which is also closed, which is also yes. These things, yes, and switch is on, switch is closed, we have given it a numerical value of 1. When switch is off, there can be no current. We have given this thing what? 0. First write down this and then we continue. Draw this figure. Do not write this part as of now, just throw down this. Write down the statement. If switch is off, If switch is off, that is, there is no current in the circuit, its numerical value is 0. If switch is on or closed, that is, a current is present, then numerical value of this statement is 1. Numerical value of this statement is 1. Now, there are I told you that mainly we are interested in AND and OR, and then there are other gates like NOT gate, we'll see that, NAND and NOR. But you will understand this whole thing with the help of AND and OR in a much better way, and therefore let's focus on these two. What's the meaning of AND? What's the meaning of OR? Let's remove this part. You know the meaning of 1, you know the meaning of 0. 1 means yes, 0 means no. Suppose I give you a circuit like this. There are two switches in this form. We'll call it switch A and we'll call it switch B. And there is another circuit in this form. There are two switches A and switch B like this. Again, current is coming from this side, current is coming from this side. Look at these two switch patterns, especially biobabel. In this, how do you explain this? First, current will flow through A. First, current will flow through A, and then it will flow through B. First, current flows through A, and then it flows through B. Whereas for this one, you can say current can flow from A or B. If you need to receive current at this place, then there are different ways. Current can flow through A. You will record a reading of current over here. If current flows through only B, then also you will record a reading of current here. So there are two possibilities. So you will say that current can flow through A or current can flow through B. This is your AND circuit. This is your OR circuit. We'll write the statements also later, but let's understand the meaning of AB, AB. If I say that A is 1, B is 1, these are the commands. Now, when I say A is 1, that means switch 1 is closed. Current can pass through it. When I say B is 1, that means switch B is also closed and current can pass through it. When you draw a circuit for this, it will look like this. These are the switches. These are the switches. You give some command at this place, you give some command at this place, and you expect a command over here. The command which you are going to receive over here, we'll call it Y. The command somebody receives at this point is Y, which you need to express in terms of A and B. Similarly here, we expect something over here, whether current is present or not, only in terms of this, yes or no. Yes or no, in terms of these, we need the values of Y. So, if somebody closes this switch, and current is coming from this side, you know that current will pass through this part, which means this Y now becomes what? Yes. Value of Y is what? Yes. If I ask you, would you expect a current over here? You will say yes. And numerical value of yes is what? 1. Now, we say that if you give two inputs in the form of 1 and 1, if you give two inputs in terms of 1 and 1 for a circuit like this, then it gives us what? Another 1. 1 means what? Yes. Yes, there is a current. Now look again. If I draw this same figure over here in this form, so what is happening? You can see that switch A is closed. That gives us A as what? 1. But you can see that switch B is open. Switch B is open, that means no current can flow through this point. If no current can flow through this point, you will say that B is what? 0. You have allowed current flow, you have not allowed current flow. Now, somebody expecting a current over here, if you ask him whether he would expect a current at this place, then I know that you know the answer, and the answer is what? No. No current can reach this place. Why is what? No. No means 0. We say that if yes and no, these two types of commands are given, yes and no, these two types of commands are given to a circuit like this, then ultimately we get no current. No means 0. Now again, I hope you can understand that by simply interchanging 0 and 1. That will be the easy case. Let's not waste time in that. If you open this, but you close it. So if you open this and you close it, will you expect any current over here? Answer is no. So, what we are getting a system like this. If someone says A, there is B, and we plot the values of Y, we write the values of Y. Current is possible, current is possible, current is also possible at the final phase. If you allow current through 1, but you do not allow current through B, then you do not get any current at the final output place, which is this. If I keep A open but B closed, I'm not drawing a circuit for that. It's very easy. Open it, close it. Since it's open, you see that there will be no current, and therefore straight away I will write what? 0. Again, if I write 0 and 0, what is 0 and 0? 0 and 0 is the same figure. A is open, B is open. If this is open, then you can see that there will be no current over here. No current means 0. This information this information which we have received with the help of A and B, inputs at A and B, inputs at A and B, and resultant outcome at Y, it is called a truth table. This truth table is for a circuit in which first current flows through A and then it flows through B. This circuit which you see is the AND circuit or AND type of logic gate. Draw this AND gate, these two samples. Wait for this. Next part will be for this one. Draw the truth table, and if you have understood a little bit of it, I'm not saying completely, then write down yes or no in the comment box. I said little bit of it. If you don't understand it completely, just don't worry. It will be all clear by the end of the class. With this figure, write down a statement. Current will flow through A. Current will flow through A, and then through B, and then through B. Underline the AND part. Show that this is the AND gate. Now this whole AND gate is represented in this form. This AND gate is represented with the help of this setup. At this point, input is A, at this point, input is B, and you receive your output Y over here. This gate is your AND gate. And this is the truth table for AND gate. Now observe one important thing for the truth table. What is that important thing? This Y now is coming Boolean algebra in very simplified form. This Y is called A plus B. This Y is represented with the help of A plus B. Now what is A plus B? What is happening with A plus B? Understand this part. Now this A plus B combination which you see in this case is, wait a second, this is not plus, this is product, and you represent this product like this, A dot B. Now this end is A into B. Now what is multiplication. What is multiplication? And this is something related to your permutation, combination type of thing. Those who are interested, I'll just give you a version of dot. Dot means product. Y and gives you a product. Those who want to understand it very fast, look here. I explained a little bit of it when I was discussing radioactivity and probability. Suppose you have got two paths and then there are three paths in front of it. First two paths are A and B. And then there are 3, 1, 2, 3. You start from this position. So, how do you explain this combination? You say that somebody coming from this side will have to choose from A and B, from this, and then he has to choose from 1, 2, 3. Suppose you start your car from here, you choose path A, and then you have to choose from 1, 2, 3. After A, one can choose 1, or he can choose 2, or he can choose 3. So how many ways you have got starting from this A1, A2, A3? Or you could have done this. Or you could have done what? If you start with B, then you can have B1, B2, B3. So these are the different possibilities. You can choose your path starting from left and to reach the rightmost position. A1, A2, A3, B1, B2, B3. How many different paths you have got? 1, 2, 3, 4, 5, 6. So how many possibilities have you got? 6. If you say that initially there are 2 possibilities, and then after you follow these first 2 possibilities, you have to take care of next 3 possibilities also. First, you will take care of 2 possibilities, and then you will take care of 3 possibilities. 2 and 3 will give you what? 6. What is 6? 2 into 3. What is AND? What is AND? What is AND? Cross. So once you say AND, those belonging to maths, they know what I'm talking about. Simple permutations I'm talking about. Especially for bio, I given you the concept behind AND. Now, we'll discuss the concept of OR when I discuss the OR table. But first of all, look at the meaning of A into B, this type of truth table over here. 1 multiplied by 1 is what? 1. Which means yes multiplied by yes will give you another yes. Yes, 1 multiplied by 0. This is simple maths as of now. 1 multiplied by 0 is what? 0. 0 multiplied by 1 is what? 0. 0 multiplied by 0 is what? Another 0. So, whenever you see AND gate, that AND gate is represented by a dot. This dot is coming from this logic, and then this dot means simple product of 1, 1, 1, 0, 0, 1, 0, 0. With OR, there will be a little bit of change. We'll see that later. But first, note down this representation of AND gate. This and then this. And this part is for those who are interested in the meaning of product behind AND gate. Put down this. Now let's see the second part. What is the second part? I told you this whole thing represents OR. What is OR? If you start from this, you can either choose A or you can choose B or you can choose both. Doesn't matter. The thing is that this is A or B. This is A and B. Now, with this, when we start drawing our truth table, it will give us these values. First, let's do it fast because you have understood the AND table. This is A, this is B. Both switches are closed. Current is coming from this side. You will definitely expect a current over here. A is 1, B is 1. Your output is also what? 1. Remember, 1 means what? Yes. If current is present over here, you will definitely observe a current over here. Yes means 1. Then, if I give you a circuit like this, where A is open. If A is open, that means A is 0. B is closed, it is 1. And this is the place, at this place, what is the output? No current can come through this path, but current can come through this path, and therefore you will definitely observe some current over here. If you will observe the current, that means yes. Yes means what? 1. Yes represents what? The 1 represents what? Yes, there is a current. Similarly, if current flows in this path, but it doesn't flow through B, a circuit like this where A is 1 and your B is 0, A is 1, B is 0, then again you know that you will expect a current that will give you what? Y equals to 1. And if you draw something like this in the original form, both are open. If A is 0, B is also 0, then you know that no current will be observed. No means what? 0. For different inputs of last one, if A is 0, B is 0, you do not expect any current at the output place. That means your Y is also what? 0. If your Y is 0, then for a circuit like this, if you draw a truth table, then that truth table will look like this. Do one thing, draw this much information. Now let's do it fast over here. Type of truth table you will expect from this. A, B, Y. 1, 1, 1, 0, 0, 1, 0, 0. When it is 1, 1, you got a current. 1, 0, yes, still you got a current. 0, 1, you still got a current. This or this, it's your wish. 1, 0, 0, no. This is the truth table for OR gate. Symbol for OR gate is this. Draw a curve like this. This is A, this is B, and over here you receive your Y. This is A, this is B, and right at this place you receive your Y. What is the value of Y? This time this Y is what? A plus B. Now, understand the meaning of A plus B and then you will note down everything. Try to understand the meaning of A plus B now. What do you mean by plus? 1 plus 1 is fundamentally what? 2. But remember, for us, 1 is what? Yes. Yes plus yes. What's the meaning of yes plus yes? Yes and yes. This is the meaning of yes plus yes. Will give you what? Another yes. So remember, 1 multiplied by 1 is 1, but remember it in this form, 1 plus 1 as a trick. 1 plus 1 is 2, but nothing can exceed 1. Nothing can exceed 1, and therefore 1 plus 1 for you is simply what? 1. Yes plus yes gives you another yes. 1 plus 0, not simple. 1 plus 0, 1. 0 plus 1, 1. 0 plus 0, 0. There is no issue over here. Remember, this is 1. Same thing. The very first one, remember the trick, 1 plus 1 is not 2, but is what? 1. Because it simply represents yes, yes, another yes. Draw this truth table. Representation of your OR gate. The way you calculate output with the help of input values. Put on everything. And for biobabble, what's the meaning of OR? How come OR becomes plus? Same mathematical logic. If I tell you that there are two paths A and B. There are two paths A and B, or you can choose from 1 to 3. Somebody coming from this side, you can go through A, B, or from, you can choose 1, 2, 3. How many possibilities have you got? Somebody coming from this has got 5 possibilities. A, B, 1, 2, 3. So in all you have got 5. 5 is what? 2 plus 3. When you write or, it basically tells you this. How many possibilities are? There are 5 possibilities. Over here, how many possibilities are? You will go through A, B. Once you have taken A, B, any one of these two, then you have to choose from 1, 2, 3 also. First go through A or B and then from 1, 2, 3. So, first go through, if I go deep in math, A or B, 1 plus 1, 2. Or from 1, 2, 3. Or 1, 2, 3. How many? 3. From these 2 and these 3. 2 and 3. 2 into 3. This is maths. If you're not interested in this much deep maths, forget about it. Simply remember, or is plus and is cross, which is dot. Cross means simple multiplication. This is not dot and cross product. We have shown this product as a dot, the usual presentation. Now, the moment you define your truth table in this form, there is a gate which is called NOT gate. Let's remove the extra part. There is a gate which is called NOT gate. What is NOT gate? It simply inverts your input. If a very simple gate, there is nothing special in this. I will directly draw a way it is represented. This NOT gate is represented with the help of this symbol. This is the symbol of NOT. Now what NOT gate does, if you send a command A, then the command you receive is A bar. What is A bar? If you send 1, yes, the final output will be 0. I am drawing the truth table. 1 bar means 0. If you send no command, if there is no command as a no, off, then it will invert the command and make it what? 1. This is a simple truth table for NOT gate. Remember what NOT gate does? It inverts your selection. If it is 1, it makes it what? 0. If it is 0, it makes it what? 1. This is called NOT gate and is represented by this presentation. A bar. What is A bar? A bar is the inversion of command of A. This thing combined with AND and OR will give you something like this. If somebody gives you a command in this form, A, B, and you expect your Y over here. What is this? This is your AND gate. This is your AND gate. AND gate followed by a NOT. It is called a NAND gate. It is called what? A NAND gate. What is the truth table for NAND gate? A, B, Y. What is Y for normal situation? A dot B. What is Y for normal situation? What is Y for normal situation? AND gate, product. But this is NAND. What NOT gate does, it gives you this. What is written here? And NOT. That is what? NAND gate. This is your NAND gate, and this NAND gate in simplified form, they simply draw the NAND gate in this way. Here are your A and B. Instead of drawing this triangle, they will give you a dot. That's all. Nothing. And NAND. This is NAND gate. What is the truth table for NAND gate? If I give you 1 and 1. What is 1 and 1? Go for the product. 1 into 1. Which is what? 1. Bar. Invert it. You get what? 0. 1, 0. What is the product? 1 into 0. Which is what? 0. 0 bar. 0 bar. 0 bar is what? 1. If I give you 0, 1, same thing. If I give you 0, 0, then you get 0 for AND. For NAND, you get what? 1. This is the truth table for NAND gate. Note down this truth table for NAND gate. Note down the truth table for NAND gate. And then I am drawing a NOR gate over here. Write down in the comment box truth table, the final Y part for NOR gate. Note down the NAND gate first. And I am writing down everything for NOR gate. A plus B bar. 1, 1, 1, 0, 0, 1, 0, 0. Write down the NOR gate truth table, complete the final part, and presentation for NOR gate. I'm removing this. Presentation for NOR gate is this. this thing is same as hold on this. Now, what is 1 plus 1? 2. No, it is 1. 1 plus 1 is 1. 1 bar is what? 0. What is 1 plus 0? 1 bar 0. What is 0 plus 1? 1 bar 0. What is 0 plus 0? 0 bar 1. Done. This is the truth table of a NOR gate given by y equals to a plus b bar. So things which you need to understand gates, the things which you need to understand is AND, NAND or NOR and your basic NOT gate which I have drawn here. Now, let's find out a bit of Boolean algebra with the help of and this is something you can expect in your board examination as well as in any competitive examination. Let's go for NAND gate first. If I give you A dot B bar, then A dot B bar is A bar dot B bar, A bar plus B bar, A bar plus B, A plus B bar. Let's say they ask you questions in this form. Let's see how much you understand. A dot B bar or a NAND gate is what? First option, second option, third option, fourth option. Let's see how many of you will answer this part. Note down this as a question. Find out which option is correct. And let's see who will answer this question first. You can also answer none of these. That is also a fifth option. Good. The correct answer is not A plus not B. What is this? Not A plus not B. So you have got what? An OR gate for not A and not B. Which means this NAND This NAND gate is nothing but, now I'll give you 30 seconds. You need to draw this, you need to draw a figure like this. And then when I draw it, if it matches with my figure, then write down yes or no in the comment box. What I'm asking you is NAND gate. A NAND gate like this is equivalent to this. I want you to answer this thing in the form of a figure. Let's see how many of you can do that. And those who want to understand how come this is the same thing, well, you can always, you've got A. The moment I give you A, what is A bar? 0, 0, 1, 1. What is B bar? B bar is 0, 1, 0, 1. So, NAND gate, but in terms of A bar plus B bar. If I write A bar plus B bar, what do I get? Remember, I will be adding information written in blue. 0 plus 0 is what? 0. Same thing. 0 plus 1 is what? 1. 1 plus 0 is 1. 1 plus 1 is also what? 1. Same truth table. Everybody in fact should write down like this. If you did in this form only, then it's good. If you did not, and if you have a different color, then A, left side A bar, right side B bar, invert the values, equal, equal. This thing is this. We are choosing blue values. This is the operator, OR. Now, the thing which I asked you to do is represent this figure, represent NAND gate with the help of OR command. So how do you draw a figure like this? This thing is equivalent to this. We are dealing with OR gate. We are dealing with OR gate. This will give us the output. The thing is, the moment I give command A, the moment I give command B, if I keep it only like this, then this Y and this Y, they are not same. This is dot, cross, this is plus, and therefore I need to invert my command. I have given what? A. Once it passes through, it becomes what? A bar. I have given B. Once it passes through this, it becomes what? B bar. Starts with A. Over here, it becomes what? A bar. Starts with B. Over here, it becomes what? B bar. You're using an OR gate, and therefore your Y is A bar plus B bar. You're using AND gate, which gives you A multiplied by B. Those of you who drew like this, that this is equivalent to this, write down yes in the comment box. Now answer this. Answer this. NOR gate, the rate was B bar. So if I give you A plus B bar, this is A bar plus B bar. This is A multiplied by B. This is A bar multiplied by B bar. This is A bar multiplied by B, or any other combination you wish. Which option is correct? First, second, third, fourth, or any other if you think is correct, write down that other option. For a NOR gate, which of these four is the correct possibility? The correct answer is, remember this, A bar dot B bar. Again, this is A bar is what? 0, 0, 1, 1. 0, 0, 1, 1. This is B. Then your B bar is 0, 1, 0, 1. So, what is Y? What is Y? This is also A bar dot B bar. This is also A bar dot B bar. Then, let's produce the truth table using blue values. 0 multiplied by 0 will give you what? 0. 0 multiplied by 1 will give you what? 0. 1 multiplied by 0 will give you what? 0. 1 multiplied by 1 will give you what? Another 1. This is same as this. So remember these formats. If somebody gives you A dot B bar, then this is A bar plus B bar. You can write down separately. If somebody gives you A plus B bar, then it gives you A bar dot B bar, like this. I hope you understand this much. Now, do the same thing. Draw your NOR gate using these commands, and then I will ask you write down yes or no in the comment box. What I'm asking you is NOR gate is this. This is your NOR gate. Representing NOR gate with the help of AND gate of A bar and B bar. Do it fast. Should not take more. This thing is equivalent to A becomes A bar, B becomes B bar. This is AND means product. Done. If you did the same thing, then write down yes. Should not take more than 30 seconds. It shouldn't take more than 30 seconds. It's this much easy. I see many of you did this. Good. Now let's write down a few things which will help us in developing truth table for circuits like these. Again, I'm telling you, remember these. This, many times people make A plus B bar as A bar plus B bar. No, that doesn't act like this. A dot B is this. Hopefully you will remember this part. And before we proceed, I'll give you a question from your NCERT book. In NCERT, they have given you a circuit like this. This is A, this is B. Write down the output, or tell me which gate do you see. Should not take more than 30 seconds. Remember, which gate do you see, or write down the value of Y. Look, how you handle this thing. The way you should answer a question like this. Command is A. At this place it becomes A bar. At this place it becomes B bar. I hope there is no confusion. Then, this is your OR gate. Forget this. This is your OR gate. I mean, if you can do it, you draw this thing as a next step. And I'm doing the whole part in the same figure only. You must draw it like this. Same figure, but I have shown you the knot over here. So, A becomes A bar, B becomes B bar. What is this? This is your OR gate. I'm not writing OR. This is the not part. Remember, this is your OR gate. The moment you reach here, it becomes A bar plus B bar. What is this? What is this? OR plus. Now, what is this? It inverts. If you give A, it makes it what? A bar. But we have given it A bar plus B bar. And therefore, look carefully. This is A bar plus B bar bar. I hope you can see the color. I hope you see the color. This is A bar plus B bar. And you are inverting it, making it A bar plus B bar whole bar again. Now, this is something we are interested in. Now look at the role of these things. What is this? A bar plus B bar, A bar plus B bar. This is something like this. What it does? It does this. A bar bar dot B bar bar. Whatever is here, bar of that. What is this? A bar. Bar of this. Dot. Bar of the next one. We are using the second property. Now what is bar of bar? Well, bar of bar. 1, bar, 0, bar, 1. This is A dot B. And what is A dot B? What is A dot B? You have got your AND gate. And everybody was shouting NAND, NAND, NAND. Do you understand it or no? Write down yes or no. The way it should be answered. Remember, and things like gates and all, which many people find difficult, but they are not. They are not difficult. If you wish, you can use a time-consuming process. Send 1, obtain the result. Send 0, obtain the result, and so on. Why waste time in doing that? This is an example from an NCERT book. And again, giving you another example from an NCERT book. And this example is in this form. The next example is in this form. Do not commit any mistake. Do not commit any mistake. It's a A and B. Well, it means that you're feeding both commands as A and A only. And they draw it like this. This gate is receiving A from both sides. Same as over here. Not. Write down the final output. Write down the final output. Which gate do you see? Use the same process. If you have to extend the whole thing, do that. No response so far. Once you develop the practice, there is no need to draw it in this form, but as of now, instead of wasting time, you can do it fast, but right now, this circuit is the same thing. AA not, BB not, and your final not. So, once your command reaches this place, it becomes A dot A. A dot A. This becomes B dot B. The moment you cross the knot, it becomes A dot A knot. It becomes B dot B knot. When you arrive at this place, it becomes, well, we can save time, but let me write the whole thing in detail first. When you reach this point, it is A dot A multiplied by B dot B and finally your not, your y is coming a dot d dot d dot. That's a not. It's a not. Now, this question can also be asked in this form. They can ask you to simplify this thing. So, directly you can see the two ways you can expect this type of question. The whole presentation is this. Now, you need to simplify this. How do you simplify this? First, let's do something over here. Something special. Which will also give us results like this. What is A dot A? There are few important things which will save your time. And since time is already up, I'm giving you these things fast. If you need to verify, you can do that. What is A dot A? A. How come? 1. If A is 1, fast. If A is 1, 1 into 1, 1. If A is 0, 0 into 0 is 0. So A dot A will give you what? A only. This is A only. If this is A only, then you are getting what? A bar. This thing is nothing but A bar. A dot A is A. A dot A is a bar. So the first part is nothing but A bar dot B bar. And the whole thing, that part use bracket, you can see it, another bar like this. So you got A bar dot B bar, another bar. Now use this one. Sorry. What is A dot B bar? What is A dot B bar? What is? Take the whole thing. Take the whole thing. Take the whole thing. You're drawing this bar, which gives you what? Which gives you A bar, this bar. What is this? Bar followed by bar, plus bar, another bar. I hope you understand what I have done over here. The blue part, whatever is in the blue, that should get another bar. This A should get the bar. Whatever is under the roof, should get the roof. Whatever is under the roof should get the roof. The thing already has a roof, makes it what? A bar bar A. So you got what? A plus B. That's your A plus B. That's the final output of this whole circuit. So what your A plus B is telling you? It is telling you that it is nothing but orbit. And that's how you simplify these things. Now, look at the second way. This is first. Now from this, you will see the second way of simplification. Let's not use this. Let's use this first. What it tells you Draw the overall bar. Look here. Draw the overall bar. Now forget about it. Whatever is under the roof, let's handle that. Whatever is under the roof. A bar dot B bar. What is A bar dot B bar? A plus B bar. So this thing in blue is A plus B bar. I hope you understand the second part. First method, second method. A dot B is A plus B. But bar and bar cancelled. You get what? A plus B. Second method, first method. If you understand both methods, then write down yours in the comment box. First and second. If you understand both, then write down yes. Well, many of you did get or good thing. Now, do some practice with these things, and you can answer any question in your school or board examination, board or your competitive examinations and all. There are certain results. I mean, some of you are going for JEE tomorrow. I'm giving you these things fast. A plus 1 is A. Remember this. If they ask you things like this, what is A plus 1? A means yes plus yes. What is yes plus yes? Yes. If they give A plus 1, not A plus 1, not A plus 1, I will ask you in fact. I just need 5 more minutes. 5 more minutes. Give me this 5 minutes. Those who are going for JEE tomorrow will benefit a lot. Maybe questions come like this. So suppose they gave you A plus 1 as A, 1, 0, A bar. These are the 4 options I gave you. Suppose a question like this comes. A plus 1 is A, 1, 0, A bar. First, second, third, fourth. Which option is correct? Write down the answer in the comment box. A is any command. What is the answer? Write down the answer in the comment box first. Good. The answer is 1. If A is 0, then 0 plus 1 will give you what? 1. If A is 1, then 1 plus 1 will give you what? 2, which is 1. So if you have got 0, then also you get 1. If you have got 1, then also you get 1. So this gives you a property, and remember it like this. A plus 1 is what? 1. Now, I'm doing the same thing with the same chart. If I ask you A dot 1, the next question, A dot 1, which option is correct? First, second, third, fourth. Write down the answer first. A dot 1, again the same chart. Which option is correct? First, second, third, fourth. Do it fast. If A is 1, 1 dot 1, you got 1. But if A is 0, 0 multiplied by 1 is what? 0. So if A is 1, you're getting 1, which is also A. If A is 0, you're getting 0, which is also what? A. And therefore A into 1 is what? 1. Write it down here. A dot 1 is what? 1. A plus 1 is what? 1. It's very simple to remember in statement form. Plus means or. Plus means what? Or. You already have a current in a branch. If you already have a current, somebody wants to visualize, then I'm giving you this. This is already 1. Now, if you already are getting a current over here, then what you do at this place, it doesn't matter. If you keep it open, you still get the current. If you close it, you still get the current. And therefore, this value is always 1. This figure is this. Similarly, you can go for A dot 1. It gives you this. It gives you this. This is 1. This is A. That's your A dot 1. That's your AND gate. That's your AND gate. Now, if you keep it open, there will be no current. No current finally. If you close it, then only you will get the current. So everything depends on what? Everything depends on what? A. That's how you answer these things. Last. What is A plus A bar? What is A plus A bar? What is A into A bar? Write down these two and then we'll finish the class. A plus A bar, A dot A bar. Let's see how many of you can answer these things. What do you think with A plus A bar? If A is 1, if A is 1, this is 0. What is 1 plus 0? 1. Which was A. If A is 0, then A bar is what? If A is 0, then A bar is what? 1. What is 0 plus 1? 1. So whatever you give, whatever you do, your final output is going to be 1. A plus A bar is what? 1. Next, A dot A bar. If A is 1, dot bar 0. This is 1, this is 0, product will be. If this is 0, this will be 1, but you are taking product with 0, and therefore that will give you 0 only. Remember these values and you can answer any question whatsoever you wish. Put on this much and then you can leave. Thank you very much.